Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. Here we have got a hexagonal pyramid, 25 mm sides of base and 50 mm axis length, resting on one of its edges of the base on the HP, and it is also inclined to VP at an angle of 30 degrees. With respect to the HP, it is inclined at an angle of 45 degrees. That is, the axis is inclined at an angle of 45 degrees. So looking at the problem statement, we can understand that it is resting on one of its edges, and the same edge is also inclined to VP at an angle of 30 degrees. So since the parameter is not going to change its length, we are going to consider this to be a non-beta angle problem. So with this input, now let us see how to draft the solution for this problem. So let us begin by selecting a continuous line of thickness 0.18 mm and draw a line and annotate that line as x and y, and also the reference planes as VP and HP. Now we shall take up the top view of the hexagonal pyramid. So let us select the line of thickness 0.50 mm and then construct the hexagon first. So the edge length is 25 and the first angle is 0 degrees, followed by the edge length of 25 and the next angle being 60 degrees, and next 25 and the angle being 60 into 2. 25 and the angle being 60 into 3, and next the edge length is 25 and the angle is 60 into 4, and then we'll complete the hexagon by drawing the line of 25 mm and the angle of minus 60 degrees, or 60 into 5. So with this we complete the construction of the hexagon. Now let us rotate the polygon as per the required condition. So select the rotate option, select the two extreme corners of the hexagon and then rotate in such a way that the two edges are parallel to the HP and then perpendicular to the VP, which makes the hexagon to rest on two of its edges. So let us consider that it is resting on this edge. So let us draw the diagonals of the hexagon to get the triangular faces. So simply connect all the corner points to get the 6 diagonal faces. So these are the triangular faces of the hexagonal pyramid. So this is the top view. Let us annotate. So let us tell that it is resting on one of its edges, AB, and the other corners are C, D, E, and F. And also the apex of the pyramid is O, and O1 is the center of the base of the pyramid. Now let us draw the front view by selecting the line of thickness 0.13. Draw the projection lines from each of the corners, that is B and A, then C and F, and also from D and E. Now let us complete the front view. So select the line of thickness 0.50 mm and then connect the end points of the projection lines. And from this, that is C and F, let us draw the axis 50. But however, here the axis line is also superimposed by the edge line, so it is not visible to us. And then connect the apex to the end points of the base of the pyramid. So this completes the front view. Let us annotate. This is O dash and also O1 dash, but this is overlapped by C dash and F dash. And here it is B dash, A dash, and similarly here it is D dash and E dash. So this completes the front view of the hexagonal pyramid resting on HP on one of its edges. So now, as per the problem statement, the axis of this pyramid is inclined to the horizontal plane at an angle of 45 degrees. So we are going to consider the front view along with the annotations. So let us create a copy of this and move it to the right hand side of the XY line. So keeping B dash A dash as the point of reference, we are going to move it to the right hand side of the XY line. Now we are going to rotate the base of the pyramid in such a way that it is making an angle of 90 minus 45. That is the angle of inclination of the base. So this is the front view of the pyramid with its base inclined at an angle of 45 degrees and also the axis inclined at an angle of 45 degrees. So if you just click this line, you can get to see that it is the inclination at an angle of 45 degrees. So now let us complete the top view for this position. So let us select the line of thickness 0.13 and draw the projection lines. So one from the apex and then rest from the corners of the bottom face of the pyramid. Draw the horizontal projection lines. So from E and A, intersect these projection lines, and then F from corner C. Now to get the apex and the axis, draw the horizontal projection. Use the trim option to trim the projection line which is not required for our constructions. Now let us complete the top view. So select the line of thickness 0.50 mm. So we'll begin with the condition, that is the edge on which it is resting. So that is B dash A dash, which is also the farthest point of the observer. So we'll just align all these annotations so that they are not overlapped by the projection lines in the next position. Okay, so now let us complete the top view. So select the line of thickness 0.50 mm, and here the corner A is the farthest point. So from the corner A and B, we are going to draw the hidden line, and this also has to intersect the corner F from corner A and then corner C from corner B. So these are the hidden lines. Now the outer edges will be the visible lines. So from corner F to corner E, the point of intersection, and this is the corner D and this is the corner C. Now draw the slant triangular faces from each of the corner points and connect it to the apex of the pyramid. So let us again select a dotted line and then connect these inner edges from the farthest corner points of B and A to O. So this is the top view of the hexagonal pyramid with its axis inclined at an angle of 45 degrees with respect to the horizontal plane. So now let us annotate. So this is the apex O, and this is the corner A, this is the corner B, this is the corner C, corner D, corner E, and corner F. This is the axis point O1. Use the trim option to trim this line, that is O01, to connect it by a center line which represents the axis. So select a line of thickness 0.13. So from O1 to O, let us connect it with the axis line. We can also trim the projection line so that the hidden line is visible. So select the trim option. So let us just trim this projection line and then use the extend to next to extend it with the dotted line. So this is the top view of the pyramid, which is having its axis inclined at an angle of 45 degrees with respect to the HP. Now he also tells that the edge on which it is resting, so here it is resting on the edge AB, is also inclined to VP at an angle of 30 degrees. So we are going to consider this edge AB and incline this at an angle of 30 degrees to the VP. So for this, let us select the line option. Select a continuous line of thickness 0.13. Let us draw a line parallel to the XY line, and then from that line, let us take a 30-degree inclined line. So this is just to ensure that the axis of the pyramid is not overlapping above the XY line. So now let us select the top view. So select all the outer edges first, and then select the inner edges, that is the hidden lines. Next, select the axis line, that is O01, and now select the annotations. Select all the 6 corners and the 2 axis points. So now let us just move this So ensure the copy is on. So keeping the point A as the reference, move this point A on the 30-degree line. Use the rotate option. So keeping A as the first point of rotation and B as the second point of rotation, we are going to rotate the edge AB along this 30-degree line. So this completes the final step, that is the edge AB is inclined to the vertical plane at an angle of 30 degrees. So you can just use the angle between options, select these two lines and then show that it is inclined at an angle of 30 degrees to the vertical plane. So to get the front view, let us draw the projection lines in the vertical plane from the apex and as well as the other corner points, and then connect them with the vertical projection lines from the top view. So let us draw the projection lines. So from corner A, okay, corner A is here, which is on the XY line. Similarly, corner B is also on the XY line. So in this case, just enter manually the angle as 90 degrees so that there is no confusion between the projection of O and the B. Now from corner C, intersect that with the horizontal projection from the corner C. Similarly from corner D, and then from corner E, and finally from corner F. So corner F is here. So now use the trim option to trim the projection lines which is not required for our construction. So these are the points. So now we'll complete the front view. So select the line of thickness 0.50 mm and select a continuous line. And then from corner A to corner B, so which is the farthest point, so it will be a dotted line. So select the dotted line. Or first we'll complete the base of the pyramid and then identify the hidden edges. So the base of the pyramid will be completely visible. So from corner A to corner B, then from corner B to corner C, corner D, and then corner E is here, back to corner F, and then back to corner A. So this completes the base of the pyramid. So now from each of the corners, we need to join that to the apex. Similarly, we get the triangular faces also. So now we can use the dotted lines to join the inner edges. So from this corner, join this to the apex O, and then join this here, and also from this point to this point, let us join the apex. So now let us annotate. So this is the apex O dash, and then this is the corner A dash, this is the corner B dash, and then this is the corner C dash, corner D dash is here, and then this is the corner E dash. Also we need to intersect O1 with O. So for that, let us try to draw a projection line from the end point, that is O1. So select a line of thickness 0.13, let it be a continuous line. So from O1, intersect the projection from O1, and from O1 to O, use the center line to denote the axis of the pyramid. So in case if you are asked to measure the length of the axis in its final position, use the distance between option. So from O1 to O, you can just measure the distance, and that is the length of the axis in the final position, which is equal to 39.53 mm. So we can annotate this point as O1 dash. Indicate the direction of the projection by using the leader option. So with this, we complete the drafting of the solution for the given problem statement. So we can just try to sum up. So we have got a hexagonal pyramid which is resting on one of its edges AB, and this edge AB is inclined to the VP at an angle of 30 degrees, which clearly gives us a clue that it is a non-beta angle problem. And we have got the axis which is inclined to HP at an angle of 45 degrees. So with this, we complete the drafting of the solution for the given problem statement. Thank you all for watching.